section 4. Oh, about that, if you all want to, we can start meeting 4 days a week now, starting next week. That way we don't have to worry about rushing. So my algebra class moved into daytime, 9 o'clock time. Okay, we left off last time. We finished example 3 and talked about example 4. Now let's look at this. Limits involving sine x over x. We've seen this before. We've talked about it before. I don't know what page it's on. So it's after that the very squiggly sine one. Yeah, it's the next one after that. So one thing we know that the limit as x approaches 0 of sine x over x equals 1 from the squeeze theorem, or from the sandwich theorem. So, and that brings about our theorem number 7. The limit of the ratio sine theta over theta as theta goes to 0. Because of the squeeze theorem, we can start applying this, where theta is in radians. Proof. Good. We'll be using this. Once we learn a theorem, once we discuss a theorem, then we don't have to go through the whole drawn out process of trying to derive it. Just whenever you see sine x over x as x goes to 0 or even to infinity, if it goes to 0, then the answer is 1. Because if in that case your denominator is undefined. Example 5. Show that. This is where yours apparently had a misprint. Y goes to 0 of cosine y over y equals 0. It's not -1, no. That's going to be one of the steps that we have to do. We have to use a half angle formula for it. So example 5, we have to go through both of these. No, this is what you put down, because you'll have, I'll tell you, this one is to erase the -1 part. Just whatever I put on the board, write that on your sheet. Because there are a few times also coming up where it didn't print out the way it's supposed to have. Look at the first one. So A. It was limit as y approaches 0 of cosine y over y. Now, can we use the theorem on this one? No, because the theorem says the limit as sine y or sine x over x, not cosine x over x. So we have to figure out some way of converting the two. The easiest way to do this is by using a half angle formula. Oh, I also have a whole bunch of cheat sheets, trig cheat sheets, algebra, and calculus stuff. I'm gonna give you all next week. Using the half angle formula, we get cosine y is equal to 1 minus 2 sine squared of y divided by 2. Because remember, we need to get sine by itself in order to use our limit. So if we subtract 1 from both sides, we get cosine y minus 1 equals negative 2 sine squared y over 2. So now we're going to take the limit of both of these sides as y goes to 0. So we have the limit of cosine y minus 1 as y goes to 0 is equal to the limit of negative 2 sine squared y over 2 divided by y. It's divided by y. So now let's look at this side. This is where the sine is. We're going to define our theta as being y over 2. We're going to define theta as y over 2. So that'll give us the limit of negative 2 sine squared theta What about this negative, the 2 over theta? This negative sign is a constant, it goes in front. That's what we get. Because if theta is y over 2 and it's on the bottom, it's going to give us 2 over, yeah. Now, if theta is y over 2 and we're dividing by theta, this is y over 2. So that means we actually flip it. So it's 2 over y. And the negative goes out in front. We don't have a sine squared theorem, do we? No. So what we're doing, oops, this is where theta goes to 0. So sine squared is sine theta times sine theta over theta. So we just take it over one of them, sine theta over theta times sine theta. Now here comes the worst part. Now we can use theorem 7. It says that sine x over x as x goes to 0. So we have a negative. This becomes 1. We're taking this limit. What happens here at sine when x goes to 0, theta goes to 0? What is theta at 0? Sine at 0. So anything times 0 is 0. All that for nothing. Those kind of equations I hate. So the hardest part was the very first part. Because we were given a cosine, but we need to be in sine to use the theorem 7. So what's the easiest function to use there would be the half angle. All right, B, let's look at B. It was the limit as x approaches 0 of sine 2x over 5x, and it equals, prove that it equals 2 over 5. In order to use our theorem, what does the bottom have to be? No, because we have sine theta, this is 2x. It has to be the same on the bottom. So it has to be 2x on the bottom. So two things have to happen. One, we have to get rid of the 5, and we have to replace it by 2. So how do we do that? So to make 5x equal 2x, what do we have to multiply to this one? 2/5. The 5s have to cancel and the 2 goes in there. So we can't just put 2/5 down here. We have to put 2 over 5 here, and we have to put 2 over 5 here. So the top is 2/5 sine 2x, and the bottom, the 5s cancel. And so we have 2x. The constant can go out in front. And that leaves us with the limit as x approaches 0 of sine 2x over 2x. According to our theorem, what is the limit as x goes to 0 of sine 2x over 2x? This goes to 1. So the answer is 2/5. We're supposed to approve. Okay, I'm not gonna lie to you. It is like a puzzle. Because you have, when you took algebra, you had to know all the rules of the basic rules of math. Then you took trig, you have to learn all the rules of trigonometry. Then you took pre-calculus, you have to learn all that. So now you have to learn all, you have to know all those rules and be able to know when to apply them. So the only way I can say is try one way. If it works, great. If it doesn't, try again. But we know that whenever we're in this situation, we're trying to try to get our function into sine x over x. So we do anything we need to make it so. Example 6. Find the limit as t goes to 0 of tangent x and secant t, 2t. I hate when they use t's. I'm going to switch to x's because I'm used to writing x's. So I have x. No, it's tangent x secant 2x over 3x. What's the first thing I have to do? Convert to what? Well, yeah, break everything down to sine and cosine. Always take it down to its lowest form. So what do we have for sure here? We have the limit as x approaches 0. This becomes 1 over 3. That one is 1 over x. Tangent is what? Sine over cosine. And then secant is 1 over cosine, 2x. Now we can move things around. The constant can go out in front. Limit as x approaches 0. We know the x has to be under the sine x. Times 1 over cosine x times 1 over cosine 2x. Do we have to do anything else? No, now we just plug in 0. Sine x over x becomes 1, which is our theorem. As x goes to 0, sine x over x becomes 1. Cosine at 0 is 1. Cosine at 0 is 1. So the answer is 1/3. Because remember, our objective is trying to get this equation into sine x over x, or sine theta over theta. Once we do that, fortunately, the rest of these are cosines, so we could just plug them in there. Cosine of 0 is 1. And the last one. Example 7. Show that for non-zero constants a and b, the limit of theta as theta goes to 0 of sine a theta over sine b theta equals a over b. So what do you think we have to do here?
Same thing, move over.
I mean, move over. I mean, we can't separate these. This is the angle.
So you can say sine A over sine B times sine theta over sine theta times A over. So you can say that.
No. No, I see what you're saying, but no, no. How did we do it last time? The 2/5 one. Can we multiply anything to the top and bottom to make them what we need? If we multiply the top and bottom by 1. Because what do we need for the sine theta? For sine A theta. And then we have 1 over sine B theta. What does this one need so we can use a theorem? And what does this one need so we can use a theorem? With this one, we can multiply A theta over A theta. And this one, we could do B theta over B theta. Those are just one. Yes, which is exactly what we wanted. So it's not going to change anything. We just change the way it looks. So now we have sine A theta over A theta times A theta times B theta over sine B theta times 1 over B theta. So what happens to this and this? What do they become? What happens to these two? As theta goes to 0. That becomes 1. That becomes 1. So all we're left with is A theta over B theta. Can anything cancel? So we're left with A over B, which is what we're trying to prove.
How did B theta over sine theta? B theta over sine theta become 1. That was
Because if sine x over x is equal to 1, then what if I had 1 over sine x over x? This is still the same because it's a quotient theorem. So that becomes x over sine x. All right, that does it for that section.